Quadratics are a really important fundamental start of the beginning of the AS course. They are going to underpin every technique and every understanding and every piece of knowledge that comes further on in the course. If you don't get them now, then you're going to give yourself untold headaches moving further. So it's really important that you get to know quadratics as they are, that you clear up any problems that you might have had with them in previous learning, and that you actually get a good sort of overview of what it is you're going to be doing with quadratics, because there's a whole lot more to them than just solving for two values of x. So the intention of this lesson is to give you an overview of what's coming with quadratics, and all the different topics that you're going to sort of do under the main topic of quadratics, and then things to look out for as you work through. So when it comes to quadratics, the first one, maybe the biggest one, is your ability to factorize quadratics. Factorization of quadratics is no longer negotiable. You're going to be working with quadratic equations, and not just your normal equations, but what we call equations that reduce to quadratics. You're going to be getting a lot more familiar with completing a square, and the incredible value of completed square format. This is the way that you really get to know your quadratic. The other big thing, of course, is your quadratic formula is not disappeared from your life. But being reliant on the quadratic formula in order to solve quadratics is not the way forward. Okay, yes, it does come up, and every now and again you will get a question which you have to solve using the formula. But it is not your go-to. Your go-to is factorization. We actually get to know that formula in a little bit more detail at AS, and in particular we're going to pull out a piece of it called the discriminant. That discriminant is such a helpful friend. Okay, it gives you information again about your quadratic. The more information you have a quadratic, the better. We also work with quadratic inequalities. And the last one, but not the least, simultaneous equations involving quadratics. Now, the other thing to bear in mind as you get started with all of this is that they can overlap. They can be part of each other. You can be doing a discriminant question, and then you have to factorize, and then you have to do a quadratic inequality all within one question. So you're moving away from that sort of discrete piece-by-piece question approach that they use at IGCSE to a much longer approach where you have an answer which takes half a page rather than a few lines. So what you've got to bear in mind is the key features of each of these and how you distinguish, am I doing this question, or am I focusing now on that, or have I got to this within the question that I am working on? So we're going to do examples of quadratic questions next week, and then you will start to see how they actually tie into each other and relate to each other. Okay, so that is a sort of list of what's coming in your quadratic toolbox. Let's have a chat about each of these in turn. So we shall start with that big one, factorization. Quadratic factorization is obviously a full lesson when it comes to your course. Here we're just highlighting on a few things. Big ones to be aware of. If you have ax squared plus bx, you've got a two-term quadratic. Okay, so for example, you've got something like let's say 2x squared plus 4x. Okay, in this one, we're just going to do a straightforward factorization. We're just pulling out the common things in the two terms and taking them to outside of one bracket. There is nothing fancy required for a two-term quadratic. So don't start turning your two terms into, oh, I need to have two brackets. No, two terms are as straightforward and simple as they look. So you just go for them just like that, looking for your common factors and taking them out. The special two-term is your let's redo that, a squared x squared minus c squared. Okay, this is your difference between two squares. Get to know him now, or he is going to haunt you during trigonometry. Okay, so this, for example, would be 9x squared minus 25. Okay, and this you can go straight, when you have a difference between two squares, you can go straight into your double brackets. 3x plus 5, 3x minus 5. We don't have to worry about splitting terms or anything funny. When we've got difference between two squares, straight out into two brackets. Okay, so when we do this in trigonometry, it's not even necessarily with numbers. It can be a sine squared and a cos squared. So that's why I say it's really important that you get to know these quadratics now while you're working with relatively straightforward numbers, and it's simpler and it's more straightforward. Then when you take it further and you build on your knowledge, you build on your understanding, the quadratics are there sitting waiting for you. They're as simple as addition and subtraction. That's what we're actually aiming for. That quadratics are simply another technique in your arsenal of being able to solve mathematics. Okay, the one that gives people headaches, ax squared plus bx plus c. Here, you're aiming for your two brackets. And this one is going to take me a little bit more. So let's work backwards. Okay, let's say we ended up with x minus 3, x plus 2. Our question would have looked like x squared minus 6 minus 3x plus 2x minus x minus 6. Okay, so in this case, we actually have an a of 1, but it works also the same kind of double bracket factorization if you're working with a which is not 1, when a is bigger than 1, and you've got 3x squared or 7x squared. Okay, so if you struggle with this, this is when you pause this video and you go somewhere else and you go look up that lesson, okay? And you make sure that you can factorize these trinomial quadratics, because these are the ones that you're going to be solving over and over and over again. So go do 20 questions, go do 40 factorizations, and make sure that you can do the two bracket factorization, because it is a crucial underpinning technique that you're going to use for the rest of this course. Now we're going to move on, however, to equations. Quadratic equations. There is a big sort of caveat here. Ax squared plus bx plus c equals 0. A quadratic equation must equal 0 before you can solve it. It cannot equal anything else if you're going to solve it. Okay. Must equal 0. The whole basis of how we understand this and how we sort of get to these solutions for this equation is reliant on the fact that they equal 0, because it's all about multiplication laws with 0. So if we look at it, if we factorized, okay, we would have x minus 3, x plus 2, equals 0. It's our helpful equation from earlier. So let's say that this equals 0. If this equals 0, well, 0 times x plus 2 equals 0, so it is true. If this one was to equal 0 instead, we would have 0 times x minus 3, and that would equal 0, because anything times 0 equals 0. And that is the basis of our understanding. That is why we then say that if x minus 3 equals 0, x equals 3, or if x plus 2 equals 0, then x equals minus 2. So we can only draw those little equations out reliant on the fact that we have an equal 0. Because what we're saying is if one of these elements equals 0, then our multiplication equals 0. So if we don't have an equal 0, then we can't be pulling out those little equations because that's what they're reliant on. And it might sound silly now, okay? But hopefully you think it's silly now and you remember it forever and you never make the silly mistakes that people do moving forward. Because it is so easy to get into funny little quirks or funny little laziness habits and you forget to have this equal 0. If you do not have an equal 0, you cannot pull the little equations. And if you cannot pull the little equations, you cannot solve the quadratic. So you must have your quadratic equal 0. You must have my solutions equal 0, and then you can pull your little equations. So even if you write less than this, even if you just write quadratic, factorized equals 0, sorry, if you just write quadratic equals 0, factorized equals 0, x equals 3, and x equals minus 2, that's fine. I don't care if you actually skip this x minus 3 equals 0 line, but you have to have this factorized equals 0 line in order to be able to get those final answers from it. So layout is essential. Communication is essential. Make sure you're showing the steps and solving your quadratic equations properly. Something you may have come across briefly is your completed square format. So now at AS, you're going to be completing the square properly and you're going to be doing it lots of, okay? What it's all doing is getting to know that quadratic better. It's getting to know, you know, what does it look like? Where is it sitting? How do I understand this graph? Because it's not only about factorizing and solving quadratics. Life is about where do they sit in my Cartesian plane? So we've got the basic of, do I have a happy graph or do I have a sad graph with my positive ax squared or my negative ax squared? But there's an important feature also of the vertex. Okay, so the vertex is either the minimum point on the graph, if it's a happy graph, or the maximum point on the graph, if it's an unhappy graph. Now, the location of that minimum or maximum can be of fundamental importance in understanding our graph. And when we move into functions, this is a very, very important feature of our quadratic, and we're going to rely on it heavily. What's really cool about that completed square format, remember he's going to look like p x plus q all squared plus r. So you may see this with a, b's, and c's. Okay, A and then a B inside the bracket and a C outside, but those are not the ABCs of our AX squared plus BX plus C. Okay, these are now different numbers. It's a different arrangement. It's a different way of writing our quadratic. So same ultimate function, but different way of writing it, which is why I use the P, Q, and R, just to give you a little bit of a reminder that this is different. What is so completely wonderful when you have your quadratic expressed in the completed square format is that you can go straight from there to the vertex. No calculations needed. From here, your vertex is minus q. So we change the sign of the 1 inside the brackets, and r. We keep the sign of the 1 outside the brackets. So just from looking at the equation of the quadratic, just from looking at that completed square format, you know exactly where that vertex is. And now you don't have to worry about finding it. You've got it. And you didn't have to calculate, you just had to look. It's a very, very, very handy thing to have around sometimes. Often, actually, more often than sometimes. So let us touch on the what you probably may have considered to be your best friend. Unfortunately, no longer a best friend. This is now just one of the things in your toolbox for quadratics, because life is not just about solving equations. So your quadratic formula, you should be completely familiar. X equals minus b plus minus square root b squared minus 4ac all over 2a. Now this formula is so unimportant that they actually put it in your formula sheet. It's there. Okay, plus it should be so ingrained in your head now because you've learned this previously. It's not something new. So we don't actually care that you can write down the formula. What we care is that you can use it. And this is another thing to remember throughout. It's not a case of writing down your formulas. It's a case of using your formulas. So if you are solving a quadratic, let's say we have 2x squared plus 7x minus 13 equals 0. Okay, we are going to be unlikely to solve this by factorization, but I'm not entirely sure because I've just made that up out of my own head. So the idea is you get to this line and you're working, and then you say, okay, right, I can or can't factorize it. If I can factorize it, boom, I factorize it. If I can't factorize it, then I'm going to use the formula. And you simply go, next line, x equals minus 7 plus minus square root 7 squared minus 4ac. No lazy square root lines, no lazy fraction lines, 2 times 2. Then you evaluate. X equals, one answer, x equals your other answer. And this is all you're writing, okay? You're not writing your formula down because we don't care that you can copy the formula down. We care that you can use the formula. So you're going straight from the quadratic itself, equals 0, into x equals, or if your quadratic's in k, k equals. If your quadratic is in d, d equals. Okay, always make sure your variable, it's the subject of your quadratic formula, matches the variable who is in your quadratic. You substitute straight into that formula. Okay, always substitute using brackets. It takes care of those negative signs. And then it's a case of plugging that into your calculator. There's no special fancy calculations on the way. If you can plug it into a calculator, you can go ahead and do it. Okay, and you get your 2 answers, changing your sign on your square root sign in between. So it's minus 7 plus, square root all that nonsense all over, 4, then minus 7 minus, all you do is that, change that sign on your calculator, much quicker approach than retyping the whole thing out again. So quadratic formula is there, it is to be used. There are questions where you will have to use it, but they pop up very few and far between. Because we've already learned this, we can already do this. This is not so much in helping us to understand what's going on. However, there is a piece of this formula that we are going to get to know a whole lot better than the more times we actually use this formula. And that piece is your discriminant. Discriminant. So this is a very new best friend. The discriminant is out of your formula. We had x equals minus b plus or minus square root b squared minus 4ac all over 2a. Now your discriminant is this piece here, b squared minus 4ac. Think about it for a moment. If you have b squared minus 4ac is less than 0, So if this is less than 0, this is a negative number. So we would be trying to do minus b plus the square root of a negative number. That's not going to work. Okay, so when we have our discriminant is less than 0, then we have no real roots. We can't solve this quadratic equation and get real answers. If we have b squared minus 4ac equals 0, then we'd be saying minus b plus the square root of 0, or minus the square root of 0. Well, the square root of 0 is 0, so we'd be doing plus nothing minus nothing. So we're not changing anything. So in this case, we'd be saying our answer when we use plus is exactly the same as our answer when we use minus. We've got two answers which are identical. So they are real numbers, but they are repeated. So we have one real root, and it is a repeated root. Now that repeated root is important because that has a meaning. We still have two answers, but they are identical. If our last option would be b squared minus 4ac is greater than 0. So now we're going minus b plus a number, or minus b minus a number. So it's going to change our answer. So in this case, we're going to get two different answers to our equation. And so we can say we have two real roots. And these ones we can say are distinct roots. So two completely different answers to this. Later on, when you work with this, you're also going to interchangeably, well, you're going to move from roots to intersections, to understanding how now quadratics relate to a line rather than just an axis. Remember, when we're dealing with roots, we are relating our quadratic to the x-axis, because the root of a quadratic is where it crosses the x-axis, where y equals 0, where our quadratic equals 0. So you start to see now how everything is tying together. But this discriminant is telling you about the roots. It's telling you information about your quadratic, but how it's sitting with relation to, at this stage, the x-axis, at a later stage, another line. It's telling you, am I sitting with no real roots? In other case, my quadratic is sitting way up in the sky. Am I sitting with one real root, which is repeated? Well, then my quadratic is sitting on my x-axis, not crossing it, but it's just touching it. So it's got the same answer twice. Am I sitting with two real roots? Well, there's your traditional one, where your x-axis is cut twice, two different answers. So you can get information about your roots. You can go work from your roots back to understand your quadratic as well. You can use everything in both directions. And so you see, we're starting to get a very powerful, very deep understanding. When we're taking the discriminant, when we're taking our completed square format, when we've got a factorized form as well, then it's all starting to come together, that we really understand what this quadratic is all about, and then where we can take it further. The last two things that you do with quadratics is your inequalities and your simultaneous equations. So these two are slightly different, because these two are where we're working with our quadratics rather than understanding the quadratic in the same way. So an inequality, we are working now through a set of steps. Okay, we're always going to end up, first off, we need to relate our quadratic to 0. We're going to then look for critical values. We're going to then equate our quadratic to 0. We're going to solve our quadratic. We're going to draw a mini sketch. And we're going to give an answer. Now this is back to front. This is the last piece of the lesson on quadratic inequalities. But why I've done it that way around is because this is the crucial piece. This is how you actually do it. So what we're doing is we're really looking at that quadratic. We're saying, okay, that's our x-axis. And we're saying, where are we in relation to zero? Are we above our x-axis in these two zones of our quadratic, or are we below the x-axis in these two zones of zero? Remember, we've related to zero in that first step. Our critical values, the solution to our quadratic, where we equate it to zero, those are going to fall where our roots are, on that x-axis. So we're taking all this understanding that we've got and we're putting it all into one question. Then we can take this technique and put it into a bigger question. When it comes to simultaneous equations, again, we're working at a broader scale. Okay, so here you're going to have often usually a quadratic equation and a linear equation. So you are always going to aim to go linear into quadratic. You want to avoid squaring your linear wherever possible. Because here we're doing another thing. I mean, here we looked at the x-axis, right? So here we're taking our quadratic and we're saying, so there's a line. Where do they meet? Our simultaneous equation is going to be those 2 points. So your sort of take-home tip for simultaneous equations when they involve quadratics is to keep your life algebraically as simple as possible. You don't have to solve for x first. You don't have to solve for y first. You have to look at that question and you have to think through what's going to happen. And then you go ahead and you do your algebra. Don't rush into simultaneous equations. Stop, look, and think first. So that is what's coming with your quadratics. Make sure that you go and you actually take the time to get each of these elements of understanding and using quadratics happy and correct and solid before you move on, because they really are going to underpin everything that is coming your way for AS Maths.